Let's kick things off with a pretty startling stat. Drug shortages affect millions of patients every single year. You've got seasonal illnesses colliding with sudden shifts in consumer behavior, making volatile pharmaceutical demand a massive real-world headache. And look, poor forecasting, that doesn't just mean a dip in revenue. It literally means patients going without critical medications or health systems bleeding cash because they overstocked on the wrong things. So today, we're unpacking a brilliant Kaggle YouTube video submission by Minahil Saba and Kamran Shirazi. They've built something truly remarkable to tackle this, called the Pharma Supply Intelligence Agent.
Okay, so let's dive into this explainer and see how we can actually move beyond those traditional, old-school forecasting methods to an active AI solution. For decades, supply chain teams have essentially just relied on passive charts. But predicting a surge is really only half the battle, right? I mean, when multiple drug categories spike all at once and you're strapped to a fixed budget, someone or, well, something has to make the hard call on what actually gets ordered. We're going to explore a system that doesn't just predict, it acts, it learns, and, absolutely crucial here, it understands its own limitations.
So here's our roadmap for today. We'll quickly frame the pharma supply problem, then look at the 5-agent system solution. From there, we'll dive into the risk and decision agent, explore memory, anomalies, and safety, peek under the hood at the tech stack, and wrap up with the real-world impact. Let's get to it.
Starting with Part 1, the core of the pharma supply problem. Traditionally, you've got a passive dashboard, right? It runs a time series forecast, flashes a big red warning about a demand spike, and stops. That's it. The human is left doing all the heavy lifting. The Pharma Supply Intelligence Agent completely flips this script because it's an active agent. It actually closes the loop. It reasons through the problem, makes purchasing decisions strictly under a given budget, adapts based on how well its past predictions panned out, and this is key, it explicitly escalates to a human manager when things get a bit too expensive.
Moving on to Part 2, the 5-agent system solution. To tackle this incredibly complex issue, Minahil and Kamran designed a highly orchestrated multi-agent architecture. It's built entirely on the Google Agent Development Kit, or ADK, and it's powered by the incredibly fast Gemini 2.0 Flash model. As we explore this, keep these 4 verbs in the back of your mind: decide, learn, detect, and escalate. This system ingests and validates sales data, forecasts volume, reasons through cross-category risk, remembers past mistakes, detects anomalies, stays safe by gating large orders, and finally acts by pushing alerts to the team. Basically, it's a complete end-to-end autonomous worker.
And the request flow, it's just beautifully seamless. A user uploads a standard CSV of sales data, boom, instantly. The data and forecast agents run complex XGBoost and random forest machine learning models to predict surges. Next, the risk agent steps up to optimize those predictions against a fixed procurement budget. If the order is deemed safe, it passes the approval gate. And finally, the decision gets pushed straight to the team's Slack workspace.
Which brings us to Part 3, the risk and decision agent.
Now, what's really fascinating about this specific component is how it's instructed to recall its own history before making a move. It's almost like a person reading their own track record. If it looks at a drug category and realizes, wait a second, I falsely predicted a surge here 3 times last month, it deliberately dampens its own confidence and trims the order quantity. It is actively correcting its own biases on the fly. How cool is that?
But of course, an agent can't just run wild. This central root agent acts as the grand orchestrator. It takes the user's budget, takes the approval threshold limits, and hands them down to the specialists. Think of it like a strict project manager ensuring the data agent, forecast agent, risk agent, and alert agent all play their parts in the exact right order. It keeps the whole operation firmly on track.
Let's jump into Part 4, memory, anomalies, and safety.
Look, in the pharmaceutical industry, you absolutely cannot have an AI hallucinating a massive purchase order. You need strict guardrails, and an AI that knows what it doesn't know. Enter capability number 1, adaptive memory. Every single decision the agent makes gets logged. Later, what actually happened in reality is recorded right next to it. Just like a seasoned human manager, if a specific drug category was repeatedly overordered in the past, the agent explicitly trims the new order. It doesn't just blindly trust the forecast, it contextualizes it with its own historical performance.
Capability number 2 is anomaly detection. Using an isolation forest machine learning model, the system actually separates the expected from the downright weird. Because here's the thing, not every spike is just a winter cold. If the historical data says sales should be flat, but out of nowhere there's this massive unexplained jump, the agent knows better than to just auto-order. Instead, it flags it as an anomaly that absolutely must be escalated for human review. And that brings us to the third capability, the human approval gate, which is where the budget threshold comes into play. The agent literally knows the limits of its own authority. If an order total is small and routine, sure, it auto-executes. But if it calculates an expensive procurement plan that blows past the defined threshold, it hits the brakes, hard. The order is paused and held for a human manager to review and approve. So you get autonomy, but with a strict, undeniable safety net.
This textbook human-in-the-loop pattern is exactly what elevates the system from a theoretical playground to something truly production-ready. Let's be real, an AI that can spend tens of thousands of dollars automatically is a massive liability. By holding orders above that approval threshold and pinging a manager on Slack, the business retains ultimate financial control, all while still automating like 90% of the analytical busywork.
Moving on to Part 5, Building the Tech Stack.
To really pull back the curtain on the build, the authors executed this over a meticulously planned 12-day schedule, turning a cool concept into a deployable full-stack application. And the tech stack? It's incredibly elegant. It merges robust machine learning models like XGBoost and scikit-learn with an agentic framework powered by Google ADK. They used Fast API for secure endpoints, and this is brilliant, they implemented a Model Context Protocol, or MCP, integration. This MCP server lets the alert agent talk directly to the company's Slack workspace, posting its reasoning and asking for approvals right where the human managers actually work every day.
And what's powering that adaptive memory and those human approval gates? Just 3 small, highly efficient Postgres tables hosted on Superbase. By simply logging decisions, logging outcomes, and tracking pending approvals, the AI gets a persistent long-term memory. It doesn't need some massive vector database. It just uses smart, relational logic to look back at what it did last week.
Finally, Part 6, Real-World Impact and Results.
Ultimately, what does deploying this pharma supply intelligence agent actually look like for a business dealing with real money and real patients? Well, the results are staggering. Using a huge public data set of hundreds of thousands of sales records, their XGBoost forecasting models explain 97% of the variance in drug demand. That is huge. By replacing passive, backward-looking charts with active agentic reasoning, supply chains can now handle sudden market volatility completely automatically. They get budget-optimal, fully auditable procurement plans without breaking the bank or worse, running out of vital supplies.
I want to leave you with this defining quote from the project. An agent that learns what to stock and knows when to ask a human. I mean, just think about your own workflows for a second. Think about those bottlenecks where you're relying on humans to read passive dashboards and make complex, budgeted decisions. How could this exact balance of absolute AI autonomy and strict human-in-the-loop safety revolutionize your own industry?